Hey, what's up guys? This video is for section 7.1, which is multiplication properties of exponents. And the way we are going to learn about exponents is when we are multiplying or maybe we are dividing different monomials. So first of all, we have to understand what is a monomial, and then we can go ahead and look at the properties of exponents. So I have the definition here. And a monomial is the product, which means you are multiplying the product of a number and a variable. So I have a list that explains and give you guys an example of what are monomials. So here's a list of monomials, and then I have a list of something that is not a monomial. But let's go ahead and continue reading the definition. A monomial cannot have negative exponents or variables on the denominator when you guys have a fraction. So let's go ahead and look at the difference between what is a monomial and not a monomial. So monomial, if you guys actually look at the root word mono, it means one. So I'm just going to circle that for you guys here so you guys can see we have monomial, which means mono means one. So when you talk about a monomial is when you have only one term with a number and a variable. So let's look at the first one, x, just the regular x. X is a monomial because it's a variable. The exponent that the x has is an invisible 1. So I'm just going to put a 1 there so you guys can see it. And the coefficient, the number in front of the x, in this case is also invisible 1. So you guys can say it's a 1x to the first power or just x. So that's a monomial, only one term. This on the right side, x plus 2, is not a monomial because you are adding a number. You have x plus 2. So when that happens, when you guys have an x or a variable and you're adding or even subtracting, like this one here, you're subtracting a number, it's not a monomial. This is actually called a binomial. We kind of look into that the first semester of the class, but this is not a monomial means one. It's a binomial because it has two terms. X is one term and the number 2 is a second term. But right now for this section we're just looking at monomials. So let's look at the next example. 2x cubed. Notice that 2 is multiplying in between. You guys have the multiplication, the invisible times symbol, times, so 2 times x cubed. So that's a monomial because it's only one term, 2x cubed. There's no plus in between, there's no minus in between. Now this one here, you don't have a minus or a plus in between the 2 and the x, but notice the x. The x has a negative exponent. And we look at the definition of monomial. A monomial cannot have negative exponents. So this is not considered a monomial. This is something else. Okay, and we're going to look into that later on in the class. But for now, this is not a monomial. The next one, negative 5xy squared. Now you guys have a number, negative 5. You are multiplying times x, and you are also multiplying times y squared. So let's go ahead and understand what this term is. So we have a times multiplication in between. We don't have a plus or a minus in between. We do have this negative in front of the coefficient. That one's okay. But if you guys have a plus or a minus in between the number and the variable, we say it's not a monomial. Now look at the exponent. The exponent is positive, so that's okay. You guys have a monomial because we have a number and you're multiplying variables with a positive exponent. This one here, not a monomial because you guys have negative 5x minus the y squared. So the minus in between the x and the y squared, that makes it not a monomial. It's a binomial. So you guys have one term and the second term is here. But like I said, guys, we're just looking at monomials today. So the last one I'm going to show you is the number 10. Any number by itself, it is a monomial. Even though you don't have a variable, it is only one term. Now, the name that we use for numbers with no variables is constant. So 10 is a constant, but it's also a monomial because it's only one term. This one here is not a monomial because the 10 has a fraction. It is on top of the fraction, and you guys have a variable underneath the fraction. So if you guys remember the definition, a monomial cannot have negative exponents or variables on the denominator of a fraction. So this one, this m to the fifth power is on the denominator. It's on the bottom of the fraction. So it's not a monomial. So now that you guys understand what's a monomial, we can actually use properties of exponents so we can simplify different expressions when you are multiplying monomials or when you are dividing monomials. So let's go ahead and look at those properties for this section. And we do have around 8 properties. So you guys are going to see more ahead. I'm just going to show you guys a few properties in this video, and I'm going to have to make another video. But let's go ahead and look at those properties. And the first 3 properties I'm going to show you are called the multiplication properties, because we are going to multiply in this section, in this video. I'm going to show you how to simplify monomials when you are multiplying those monomials. So notice that every property has a name. So we have the product of powers. That's the first property. So this is the actual property. I'll explain that in a second. We have property number 2, power of powers. So this is what it looks like. And number 3, power of a product. This is what it looks like. Now you guys also have to remember what is the base of an expression with an exponent and actually what's an exponent. So that's why I have this down here. So remember that the number on top of the little number on top of the big number. So b is going to be a number. It can also be a variable. But you guys have a big number. For example, here we have a -2. Well, that's called the base. The big number 2 in this case is the base. The exponent is the little number on top of the base. So you guys have -2 to the 4th power. Now we say power, but it is called an exponent. So this one, you guys have -2 to the 4th power. Sometimes you might have the same expression, but with parentheses, -2, and you guys have an exponent outside the parentheses to the 4th power. So you guys have to understand the definition of exponents so you guys can simplify different expressions. So let's go ahead and talk about this first. -2 to the 4th power, what does it mean? And then we'll talk about this one. And after that, I'm going to show you guys the 3 properties. So keep in mind that an exponent, this one tells you how many times you are going to multiply the base by itself. So in other words, you do not multiply 2 times 4. So the answer is not 2 times 4. Oh, that's 8. It's wrong. You guys have to multiply the base by itself 4 times because the exponent is 4. The one on the bottom, it has parentheses with the -2 inside and the exponent 4 is outside. So let's understand the difference between those two, and then we can actually understand the properties of exponents. So let's do this one. When you guys have a negative number, for example, -2 to the 4th power with no parentheses, what this means is you guys are going to keep the negative. So I'm going to put equals here, negative, and you are going to multiply the base, which is 2, to the by itself 4 times. So you multiply 2 times 2 times 2 times 2. Notice that I didn't write down the negative 4 times. And that's what you do. If you do not have parentheses, you keep the negative only 1 time and you multiply the base the number of times the exponent is. So if you guys have an exponent of 3, you multiply 2, the base, by itself 3 times. In this case, we have a 4. So we multiply the base, the number 2, by itself 4 times. So my answer is going to be, I keep the negative right here. That's the one I have at the beginning. So this negative is right here. And then I multiply 2 times 2, which is 4. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So my answer is -16 when you guys don't have parentheses. Now at the bottom, when you guys have parentheses and the negative is inside, I showed you guys a trick last semester, but I'm going to do this the long way first, and then I'll show you guys a trick of how do you know what is the answer depending on the exponent and you have parentheses. So First of all, the definition is you guys will multiply what's inside of the parentheses by itself 4 times, and that's including the negative. So when you guys have those parentheses, you are going to multiply -2 times -2 times -2 times -2. So you multiply 1, 2, 3, 4 times. So here is where you guys have to be careful, because when you multiply -2 times -2, that's +4. +4 times -2, that's -8. -8 times -2, that's going to be +16. So my answer is a +16, because when you guys have even number of negative, your answer will be positive. So that's the trick. If you guys have even number of an exponent, so the exponent is even, 4 is even, 2 is even, 6, 8, 10 is even, your answer is going to be positive. If you guys have parentheses, and let's say that this exponent is an odd number, so to the 3rd power, or 5th power, or 7th, 9th, 11th, that's odd. You guys will have an answer that is negative, because when you have odd number of negatives, the answer stays negative. And that's the trick that you guys need to know. So let's go and understand now what are the properties of exponents. So I'm going to zoom in here so you can actually see property number 1. And property number 1 is when you guys have the product of powers. So here's the actual property, and in the middle it explains what it means. So I'm just going to read what it says. When you have the same base and you are multiplying the bases, you add the exponents and keep the base. So notice what it says here. A, that can be a number, or it can be a variable, to some power, so a to the n power, and you multiply by a to the n, so this is going to be a different number, but we have the same basis. Notice there's the a here, there's the a over here. So when you multiply a to the n power times a to the n power, that's going to equal a to the m plus n. So you add the exponents. You keep the base and you add. So here's an actual example with numbers that you guys can actually see. So we have 5 to the 3rd power times 5 to the -1st power. I know that's negative, but you guys can have exponents with negative, and we'll talk about that on my next video. But for this example, you guys will understand what I mean. Notice we have the same base. 5 to the 3rd times 5 to the -1st power. So I keep the base. There's the 5. I'm going to add the exponents. 3 plus -1. So notice I'm adding the exponent. 3 plus -1. 3 plus -1 is 2. So I keep the base, 5, and my new exponent is 2. Now I can simplify this. 5 squared is 5 times 5. You multiply the base 2 times. So the answer is 25. The next property is called the power of a power. So the power of a power looks like this. You have parentheses. You guys have something to the exponent, so a to the n power. And all of this is raised to another exponent. So you have a to the n power to the n power. So in a parenthesis, if you have an exponent inside and an exponent outside, you will distribute or multiply the exponents. Okay, so you guys are going to multiply this one times the one inside. So m times n. Notice this is multiplying right here. So I give you guys an example. 3 to the 3rd power. So you guys have that base to the 3rd power. And all of this is to the 2nd power. So what you can do is you can multiply the exponents when you have parentheses. You keep the base. So there's a 3. You multiply the exponents. 3 times 2. That's 6. And you guys can use a calculator to simplify this here. 3 to the 6th power is 729. The third property is called the power of a product. So product means multiplication. What that means is you are multiplying something inside of parentheses. So for example, we have a times b. There's nothing in between, so by default they're multiplying. You guys can have 2 variables, 3 variables. You can have a number inside the parentheses with a variable. You can have 7x. You can have 3ab. So, or you guys can have 3 different variables. But when you guys have something inside of the parentheses and you are raising that to a power, you are going to distribute and you're going to multiply the exponents inside times the one outside. And let me zoom in here so I can show you what I mean. So you guys are going to look at the exponent of the a, and this one has an invisible 1. You guys are going to look at the exponent of the b, and it also has an invisible 1 exponent. And you guys are going to multiply this exponent times the exponent of the a and the exponent of the b. So it's very similar to the one up here. Remember I told you guys to multiply those two exponents? Let me just draw an arrow so you guys know. I'm going to multiply the exponents here, m times n. So here you just do it 2 times. You multiply m times 1. You keep the base, so a to the n power, and b, there's the base, and m times 1 is m. So here I show you guys that, or it says, remember to distribute the exponent to whatever it's in the parentheses. Okay, so if you have something inside, you multiply by what's outside. Let me show you guys an example. So you guys have parentheses 2 times 3 to the 4th power. So you guys can put a exponent of 1 to the 2. So there's a 1 right there. Exponent of 1 to the 3, because there's an invisible 1 for each one of them. You're going to multiply the 4 times the 1, 4 times the 1 here. So you keep the base of 2. 4 times 1 is 4. You keep the base of 3 right here. 4 times 1 is 4. You guys can simplify that. 2 to the 4th power, that's actually multiplying 2 by itself 4 times. So you can use a calculator, or you can multiply 2 times 2 times 2 times 2. And that's going to be 16. And then you multiply 3 to the 4th power. So that's 3 times 3 times 3 times 3. And that's going to be 81. And then finally you multiply 16 times 81, which equals 1,296. Now, if you guys don't have variables, like this example here, well, you guys can actually multiply using the calculator. But if you guys have variables, you cannot use the calculator to multiply everything in that expression. You can do little pieces with the calculator, but you really need to know what to do when you have variables. So let me just zoom out here so you know what properties we are going to use today, the multiplication properties. And we are using the product of powers. So that's the first property. Power of a power, second property, and power of a product, third property. And again, guys, make sure that you also remember what happens if you have exponents with negative numbers. And sometimes you might not have parentheses. Sometimes you might have parentheses. So you also have to be careful with those signs. Okay, so let's go ahead and try property number 1, which is you keep the base when you multiply and you have the same base. You keep the base and you add the exponents. So let's look at this example. We want to simplify. We want to know what is the answer. So we have 2 to the 3rd power times 2 to the 5th power. Notice they have the same base, 2, 2. So I am going to keep the base and I am going to add the exponents, 3 plus 5. So when you guys multiply and you have the same base, you add the exponents. So this will be 2 to the 8th power. Now you guys can use a calculator or you can multiply by hand, but remember that 2 to the 8th power, that's actually multiplying 2 by itself 8 times. So it is not 2 times 8. That's a very common mistake. You do not multiply 2 times 8. Oh, the answer is 16. That is wrong. You will multiply 2 by itself 8 times. So it should look like this. 2 times 2 times 2, that's 3 times 2 times 2 times 2, that is 6 times. 1, 2, 3, 4, 5, 6. This looks like a 1, so let me do 2 right here. 7 times, 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So you multiply all of this right here, and when you guys multiply, you get 256. So that is your answer, 256. So this is the property of exponents. If you guys are multiplying two terms, and these are monomials, this is one term, it's a number with an exponent. So you have a monomial times a monomial. So when the monomials have the same base, you guys keep the base and you add the exponents. So you guys take the 3 and the 5 and you add. And then you guys simplify that expression. Let's look at the next one. The next one is very similar to the first one, but notice that we have parentheses. Now in between, there's nothing of the 4 squared and the 4 to the third power. So you guys can use the product of powers to simplify the expression, because by default, since we don't have anything in between the parentheses and this expression monomial, we are multiplying. So I'm going to keep the same base, and my base is 4. Notice 4 squared times 4 cubed, and that's what we say with exponent of 3. You can say cube or to the third power. So you guys are going to keep the base 4, and you guys are going to add the exponents 2 plus 3. So you guys keep the 4 here, and 2 plus 3 is 5. And then you guys can use a calculator to simplify 4 to the 5th power, and it equals 1024. So my answer is here. And we are using the property of exponents to simplify that expression. Now the next ones don't have numbers, they actually have variables. So we have p to the third power times p to the 5th power. These are monomials because it's only one term. You have p with an exponent, the exponent is not negative, and you guys don't have a fraction with the variable underneath on the denominator. So it is a monomial. So we're multiplying a monomial times a monomial, p to the third times p to the 5th. So what we do, guys, properties of exponents, when you multiply monomials and you have the same base, p, and there's another p, you guys are going to keep the base. So there's the base p. We are going to add the exponents 3 and 5. So 3 plus 5. So you simplify p to the 8th power. 3 plus 5 is 8. Now guess what? P to the 8th power, we cannot do anything else. A variable to the 8th power, you cannot. The definition of exponents, this right here is multiplying itself 8 times. So you can multiply this base, the p, by itself 8 times, but you don't have to write it down because the simplest form is here, p to the 8th. So that is my answer. Now, the next one, you also have variables here, but we have a monomial with a coefficient. 4 is your coefficient, your number in front of the variable. So 4m squared, that's a monomial, times, I don't have anything in between the parentheses and the monomial, 6m to the 7th power. So in these cases, guys, what we do, notice that the numbers coefficients are not the same basis. So you guys do not keep, let's say, the 4 or the 6. What we have to do is actually multiply those coefficients. If the coefficients are not the same, or even if the same, and they don't have exponents, you can actually multiply. You have to multiply those numbers. So I'm going to multiply the 4 and the 6. So I'm going to write it down here. 4 times 6. So this coefficient times this coefficient. But the variables m squared, and I'm multiplying m to the 7th power. Those have the same base, m and m. So I am going to multiply or keep the m. Notice here's the m, but I'm going to add the exponents. When you guys multiply the same bases, you guys add the exponents, 2 plus 7. You guys finish the problem. 4 times 6, that's 24. And m, there's the m, and 2 plus 7 is 9. Now my answer is 24m to the 9th power. Because m to the 9th, you guys cannot do anything. You cannot simplify. And you already multiplied the numbers. 4 times 6 is 24. So this is my answer. Now for this example, I'm going to use the power of powers to simplify the expression. So let's go ahead and understand what that property is. When you guys have parentheses with exponents inside and exponents outside of the parentheses. So let's look at the first one. 3 to the 4th power times, 3 to the 4th power raised to the 2nd power. So we have an exponent 4 inside, exponent 2 outside. So what we do in these cases, we keep the base inside, and I'm going to multiply the exponents. Notice that with parentheses, I will multiply. So I'm going to take this here, and I'm going to multiply the exponent inside. So I keep the 3, and I multiply 4 times 2. So 4 times 2 is 8. So I have 3 to the 8th power. Now once again, you can actually use a calculator. 3 is a number, it's not a variable, and we can simplify, or you can multiply the base 3 by itself 8 times. I'm just going to use the calculator, and the answer is 6,561. And that is 3 to the 8th power. Now the next one, you guys have brackets. We have 2 cubed to the 2nd power, but also we have raised to another 2nd power. Now remember that brackets are the same thing as parentheses. So even though you guys have 3 different exponents, you have parentheses and brackets, you're actually going to multiply all those 3 exponents. So you multiply the 2 times the 2 here, and the 2 times the 3 over here. So I'm going to do this step by step so you guys understand where the numbers come from. So I'm going to do what's inside of the bracket first. So this bracket right here, I'm going to multiply the exponents because I have a parentheses, and I'm going to take the 2 times the 3 inside of the parentheses. So I have my bracket here. I keep the base is 2, and I multiply 3 times 2. So I'm going to write it down. 3 times 2, there's a bracket, and there's the exponent outside of 2. Now 3 times 2 is 6. So I have 2 to the 6th power, brackets, and then another 2 over here. So now I'm going to distribute the 2 outside inside of the bracket. Bracket is the same thing as parentheses. So I keep the base 2, and 2 times 6, I'm going to write it down. 6 times 2, or 2 times 6, is 12. So I have 2 to the 12th power. 2 times 6 is 12. Now you guys can use a calculator, and you guys can simplify 2 to the 12th power. And the answer is 4,096. So we can use, again, a scientific calculator. You guys can use the exponent button. So we have 2 to the 12th power is 4,096. Now the next ones have variables, but the idea is the same. You guys have a variable inside to the 5th power, m to the 5th power, to the 9th power. So parentheses, this is property number 2. I'm just going to show you guys that property number 2 right here. So we are going to distribute or multiply the exponents. So I'm going to take the 9, and I'm going to multiply by the 5. So I keep the base. My base is m. I multiply 5 times 9. So I have m to the 45th power. 9 times 5 is 45. So my answer is m to the 45th power. That's it. We cannot use a calculator because m is a variable. You just leave it as a variable, m to the 45th power. The next one, same thing. You guys multiply the exponents because we have parentheses. We keep the base, and I'm going to multiply 4 times the 7. So I keep the x right here, and I multiply 7 times 4. So once again, keep the base, and 7 times 4 is 28. So my answer is x to the 28th power. You keep the base and you multiply the exponents because we have parentheses, and we have an exponent outside and an exponent inside of the parentheses. Alright guys, so this concludes my first video for this section, properties of exponents, and we are just looking at 3 properties, but remember that we have about 8 properties, different properties, and I need to talk about the third one, but now I'm going to have to do a second video because there's more stuff to show you guys when you guys simplify using properties of exponents. And if you guys like my videos, you guys can hit that like button, and you can also subscribe to my channel so you guys are up to date of my videos. Make sure you guys practice, and I'll see you guys later.